This video was brought to you by Markus Bil, Elbilmek, ABRP, Stormberg, Kempower and Bilkomponenter. Yo, what's up? We're now at the Morrow factory in Norway, Arendal. Wait, is my hat not properly there? Okay, so we have to wear all the safety equipment. We're gonna do a little factory tour. I have done in a factory, I've been in a factory in Giga, Nevada a long time ago, but this is in Norway and it's going to be a battery factory.
Yeah.
So we may have Andreas. You will do the stuff, show me the stuff here. So let me just move over here.
Good, good. So this is a layout of our battery factory. So we came in through here, and through the high part of the building. It's 20 meters high, and now we are in the actual production area around here. The factory is laid out to produce a capacity of approximately 1 gigawatt hour. So, I mean, we can really call that a gigafactory. We will employ about 150 people to operate this facility. And I mean, what is part of the DNA of Morrow is, of course, to operate this facility with 100% of renewable energy. And as Rahul already mentioned to you when we came in here, we will start production in this facility in the second half of this year. So I'm now guiding you through this facility. I mean, we are in the middle of the installation of all the production equipment. The process will run in a counterclockwise direction. So here in this part, we plan to have the active material production. At the beginning, we will source materials from outside vendors, but as we develop our operations, we also plan to integrate into active material production of the second generation battery technology, which is the LNMO. Then here in this part, in this part of the building is the mixing room. We have this divided in a two-floor operation. At the top, we have the powder input, powder mixing. Then on the first floor, and I will show you more when we go in, we have our large barrel PD mixers. We transfer the slurry into the coating line, which is to the coater. We have two coaters, a coater for the cathode side, a coater for the anode side. It's actually quite big equipment. The whole equipment is about 90 meters long, and you see that when we go into the room, here in this area of the operation, we have the calendering, so compressing the electrodes after coating and drying, and then the slitting into the which we will later operate or use the electrodes. We pass through a vacuum dryer, and all this area is then reserved for the actual cell assembly. Not sure whether Rahul explained to you, but we plan to produce large format prismatic cells. So it's a prismatic cell assembly consisting of notching, stacking, and then assembly, which includes basically insert of the electrode in the can, electrolyte filling. And then we move into the higher part of the building to finalize the process, and we transfer the cells for the final process step, which is the formation. And then we package it, or we finally inspect the cells, and we package them, and then we transfer them to our customers.
So this kind of cell production requires some electricity, but also what about water?
Actually, the water consumption is, the actual water consumption is very little, because we need some water for the slurry mixing of the anode slurry, but it's not really big water, and we need water for cooling. But our cooling system here is designed that it's a closed loop system. We use a high degree of natural cooling, and when in cases it's very warm outside and the natural cooling is not enough, we also have glycogen cooling, but we have really designed it to operate at a high level of natural cooling. And as I mentioned, this is a closed cooling system, so we do not have to basically replenish with water or use outside water for cooling. So the water consumption as a whole for this facility is, very, very small. So this is now our planetary mixer we use for the slurry mixing. It's it has a capacity of about 2,500 liters, so it's quite big, and we use this to prepare our electrode slurry, and then we, as I mentioned before, the powder comes from the second floor and then goes into the mixer. We mix it, powder, binders, conductive agents, and also solvents, and after mixing is complete, we transfer it to storage tanks, and from the storage tank it goes through a pipeline system to the coater, which is actually over here. So now we arrived at the coater, and we are actually inside of the coater. We are inside of the drying chamber, and I mentioned to you before, the coater itself is 90 meters long. And here inside the drying chamber, which later on we will not access because it will be quite warm in here, but this by itself is 60 meters long, and we have actually two levels here. So we have a drying chamber for the first side coating on this first floor, and we have the same drying 6-zone drying chamber on the second floor for the second side coating.
Oh, above us there. Right. Well, I heard that there are lots of Koreans here.
Yeah, absolutely. Absolutely. I mean, we purchased all our equipment from leading equipment suppliers in Korea. I mean, as probably people know, Korea is the leading country, I would say, besides China, in lithium-ion battery production at large scale, and so a lot of the supplier base for equipment.
But also the workers.
Yes, the equipment suppliers are located in Korea, supplying to manufacturers like Samsung, LG, and SK On. And of course, to install that equipment, we need their experts to do the installation activities, and therefore these equipment suppliers, they have brought their own expert to come here and install the equipment.
Well, how many Koreans are working here then?
Of course it varies, but at the peak we will have about 200 people from Korea here.
Well, it's like Koreatown here.
Yeah, right.
I also heard that you have a big Korean restaurant.
I mean, they serve Korean food. I mean, we like to cater for those people, and also want to give them a piece of home, and we serve some Korean dishes. I mean, of course, the most probably unique food we are serving is kimchi. I mean, Koreans cannot be without kimchi, so we have our chefs here. They prepare kimchi, and I think that gives the people a piece of home away from home, and it's very important. I mean, they are here for weeks, if not months, and giving this little bit back to them is very important for their well-being. So we have really put a lot of emphasis on that.
Okay, can we film this part of the?
Yes, you can.
Room?
You can film this part of the equipment.
But some stuff here is secret, so I have to ask always, what can we film here?
Yeah. So I mean, this is our calendar, where we basically, after trying the electrode, it's used to compress the electrode to the required density, at the required thickness, and the required porosity. And actually, how this works is we have two rotating rolls that insert really a high pressure on the coated foil to bring it down to the right compression level. Yeah.
How big was it, Andreas?
I mean, this equipment, what we see here is about 40 tons. So it's really heavy, and it took a lot of effort to lift in. So it's a heavy piece of equipment, but it inserts a very high pressure, and therefore we need a very rigid frame, heavy 6 steel frame to be able to insert those pressures. And I think what's really quite impressive about this equipment, after calendering, the tolerance of the electrode thickness is in the range of plus minus 1 to 1.5 micrometers. So we are, I mean, battery manufacturing by itself is also a high precision industry.
Yeah, maybe I'd like to comment on that. Stay close to his microphone. A human hair is only 100 micrometers. So when he says 1 micrometer, we are talking about 1/100th of a human hair. So you have 1 meter long or wide sheets you're coating, and you want almost 1 micrometer of precision in coating edge to edge. So that requires extreme sophistication in and control. And yeah, so that is a challenge, and also the beauty of the battery manufacturing.
And also I wonder, this factory, does it have many robots automating things, or do we still use lots of humans? Or?
Yes, actually, I mean, of course, we cannot eliminate the human expertise from a sophisticated and high precision process like this. So we have operators monitoring the process, but we are aiming for almost 100% automation. So the people required here are to monitor the equipment, control the equipment. However, the material flow, so the transfer from one process to the other, is conducted by robots. I mean, we call it AGVs, automated guided vehicles, to move the product from one process station to the next. Actually, what we haven't talked about yet is the battery production takes place in a clean or a cleanliness controlled and also a dry room environment. So the area we are now, especially for the cathode processing, takes place at the humidity of below 1% relative humidity, so it will be extremely dry in here.
Wow, super dry. You can't get that normally.
It's super dry, yes. I mean, we are talking here about the dew point of minus 50 degrees, so you cool down the air to minus 50 degrees to get rid of all the humidity there is in the air, and then of course you heat it up again. The actual room temperature inside here will be around, during operation, 22 degrees, but it has actually the humidity level of air at minus 50 degrees. So you have to feel, I mean, if you're at the North Pole at minus 50 degrees, that's how dry it will be in here later on. So as I said, humidity below 1% relative humidity, and then it's also cleanliness controlled. And you see these air filters at the ceiling, we call those fan filter units. And we are looking at the very low ratio of airborne particles in this air. Particles, especially conductive particles, are very detrimental to the batteries. They can create shorts. And as the separator thickness is about 7 micrometers, so very, very tiny, thin, a particle that is thicker than 7 micrometers can actually damage the particle, can damage the separator, can create a short, and the short is very harmful for a battery, internal short. I mean, in best case, it leads to a dysfunction of the battery. In worst case, it can lead to a short and a fire incident. So when people talk about battery fires, very often they can be caused through internal shorting of the batteries, and of course that's what we want to avoid, and therefore cleanliness control inside of a battery production is really the key factor to focus on.
And will you say that once this room is in production, is it going to be cleaner than in a hospital?
Similar. I mean, it will be a perfectly shiny, clean floor, and I mean, operators will be continuously reminded to ensure a high level of cleanliness. And as I said, the system is set up to make the whole area as clean as possible. So what we see in this room this is where our cell assembly will take place. It's We will start equipment installation next week, so that's why this room is still empty. We will have notching, stacking, and then cell assembly equipment in here. The room itself is about 100 meters long, 15 meters wide. So we need quite a lot of space for the cell assembly, and this is actually, from an environmental condition, the most stringent environment to operate, because we will process, we will fill the electrolyte in here, and therefore we need very, very low humidity conditions. Again, you see at the ceiling the fan filter units to ensure that we have that we ensure high level of cleanliness. It's also critical in here. And you see that we are just covering what we call our epoxy floor. This has two purposes. One is to ensure from electro discharge, and the second is to ensure high cleanliness.
Those filters, I see them everywhere on the roof.
Yes.
How often do they need to be replaced?
Actually, the filters, I mean, it's normal maintenance. It's about every 6 months a filter has to be replaced. So.
Wow, that is a lot of work, because there are tons of these on the other room also there.
Yeah, sure. I mean, it's of course it's one of the key process requirements, so it takes some effort. But I mean, we have to do regular maintenance and review that things are working properly every couple of months anyway. So this will be part of that standard routine.
Yeah. Wow, and I can imagine once you try to replace one of those filters, they have lots of dust. So you have to somehow.
No, actually, I mean, you know, we don't bring actually dirt inside. So the actual dust that has to be filtered out will not be that much, because the room is isolated. So it's completely sealed, and the only entrance to this room is through so-called air showers.
Oh.
And so the dust actually people carry on their clothes is showered off.
It's like semiconductor man.
When they enter the room, and we also have a special protective dust limiting clothing people have to wear when they enter this room. So I mean, it's not as much as you may believe, because it's
especially in this unit, it's very.
Yes.
So if there will be a virus outbreak, this is the place to be.
What's that?
If there will be another virus outbreak, this is the place to be then.
Probably.
Yeah. COVID would not survive
yes.
here.
Probably, yeah. So that's where we'll all gather in the next pandemic, yeah. So now we arrived in the final process, which is the formation, and the first step in the formation is actually the charging and discharging of the battery cell, which is the actual activation of the battery. So we do this in equipment like this. This area we have built quite high to save space. This setup here, we are charging on 5 levels. It's 13 meters high equipment, and we will feed this equipment with a fully automated stacker crane system. So you can imagine like the operation here, like in an automated warehouse. Trays with cells come in, they're fed into the charging unit, they're left there for a period of time, and then after the charging has been completed, they are moved out by the stacker. I mean, the tray where cells are placed are moved out by the stacker crane again, and then they're moved to the next process, which is aging. And I'll show you that to you in the next sequence. Yeah, and that's what's happening in here. Yeah.
But it can be. I mean, it will generate some heat, the whole charging here. So the room might be hot then.
Yes, absolutely. When you, of course, when you work with electricity, and when you charge a battery, it gets hot, and therefore we will actually generate a lot of heat here. As I explained to you before, we have a cooling system, And for most part of the year, we operate that cooling system with natural cooling using outside air. And we are quite fortunate in Norway that for most part of the year, we have the outside temperature is actually lower than the temperatures we operate in here. Here we operate at the room condition of about 23 to 25 degrees. And yeah, as I mentioned, luckily for most of the part in Norway, it's below that temperature. So we can use outside air for the cooling. And as I mentioned to you before, this is, I think, what makes Norway a quite favorable location for this type of production, for battery production, if you compare us to a location in Asia, especially Southeast Asia, where the temperatures are very high, also humidity is very high. You need a lot of energy to cool your air, to get out the humidity on the one hand, and also to cool down the air to reach your proper process temperature. So in the overall energy balance, battery production in Norway is actually quite beneficial.
Interesting. I never thought of that. Plus that the electricity here, yeah, you also mentioned it. Well, I can tell it's a factory, but it's 99% renewable energy. Whereas in China or Korea, it might be a dirtier mix. So yeah, that's pretty good.
Yeah, absolutely, absolutely. So now we arrived in the second main process of the formation, which is the so-called aging. And we have actually two different rooms for the aging. One is the so-called high temperature aging, and when we talk about high temperature, it's about a temperature of 45 to 50 degrees. And here is the room temperature aging, and room temperature means, yeah, like normal temperatures, and we control that environment to 23 to 25 degrees, so pleasant temperature. And this is where the cells are kept for a period of time to develop all the oxidative layers and also to prepare them for the final inspection. And how this room is actually set up, it's basically a warehouse. We have later on a stacker crane running through that warehouse, and the stacker cranes will then place the cell trays. So we have in each tray, which is about 1 meter by 1.20 meter large, we have 32 cells in one tray, and then they are fed into these shelves and left there for a defined period of time until we then move them to the final inspection. So in essence, it's really a warehouse, and you see it, it's very high shelves where we can store our goods, our precious products. And here we have built 17 meters high, so it will be a fully automated warehouse when it's under operation.
So there'll be a robot here going?
Yeah, there will be a robot going, right? We call it a stacker crane, but it's basically a robot that lifts basically the boxes into the shelf.
So the batteries, they're like meat, they're like beef that needs to be dry aged.
Yeah, exactly. So maybe some of the employees want to bring their sausages and their ham and put it into the controlled temperature aging environment. Yeah.
Okay, so we are outside the factory now, and just to show you how big this factory is, so you can pan over there. It's how big is this factory again?
Yeah, actually the factory is 240 meters long and 84 meters wide, the main building. And it's definitely quite sizable industrial building. Most people may not recognize how big battery production facilities are. But if you actually zoom over there, this is where we plan to build our gigafactory. And it's actually the gigafactory, the first module we are planning to build will be a building 400 meters by 200 meters wide, and it is planned to have a capacity of 14 gigawatt hours. So you need a lot of space.
Wow.
Yeah?
So the 1 gigawatt hour was this?
Yes.
Only? Wow.
The 1 gigawatt hour is this, and over there we plan to build the first of our 3 modules, which will be 400 by 200 meters wide, only the building. Yeah. And the total land plot that we have reserved here is 1 million square meters. So what you see here to the end, where the trees start, is only 1/3 of the building that Arendal community allocated to build future battery production here in Arendal.
Wow. That is impressive, man. The size here.
Right, right.
But okay, now you guys have just seen an unfinished factory. So eventually we should come back here again in 6 months, or when?
Yes, if you come back after the summer break, we plan to produce the first cells. In fact, we plan to produce the first cells, of course, much earlier during equipment commissioning. But like cells that are ready for customer delivery will be from after the summer break in July, August time.
Okay. Yeah, great. Then it won't be too much snow and not too cold.
Yeah, hopefully.
So I should be
But we have to operate the cooling then. Yeah.
Yeah. But okay, I'll be back again then and see how the factory is operating.
Cool.
Yeah.
Okay.
But
look forward to that. Yeah.
Yeah. Thank you very
Yes.
much for the tour. Somewhat exclusive tour, hopefully.
Yes. Absolutely. I mean, you got a very special treat today.
So anyway, guys, I think that's going to be it for now. I hope you guys enjoyed this video. As always, thank you for watching and talk to you later.